Okay, so we're going to be talking about in topic 9 some concepts around network security solutions. So, some of the stuff we've talked about, we're going to be talking about here, is something we've had some conversations about, something we've seen in some other um, earlier. We talked around firewalls, we've talked around port security, and intrusion detection and prevention systems. So this deals with in the Security Plus Essentials book, chapter 6 and 11. And also, there's a couple articles here, a couple NIST articles as well, which would be good reference around kind of what some of these different concepts around firewalls and intrusion detection. All right. So we talked about this idea of a firewall. So the idea of firewall is you put a filter. In effect, what it is a device that provides a filter to separate the inside from the outside, from the internet from the intranet. All right. And the idea is that the way it works mechanically is that everything that passes from the internet um, through into the intranet is basically viewed. Every packet that comes in is reviewed, looked at, matched up against a set of rules, which will make a determination of whether or not it should be allowed to proceed. So this is really kind of a fundamental, as we talk about firewalls, it's the fundamental building block of perimeter security in networks. As I said, protect outside attackers from offensive websites. Some of the key issues, shield computers from malicious and unnecessary internet traffic. As I said, the thing you see right now, if you put an unprotected machine directly onto the internet, within minutes it will begin to be scanned because basically there's machines and folks that are out there, that's basically all they do. They're constantly looking for new devices and getting insights and understandings about what's out there, what's running, how it's running, software it's running, things of that nature. Firewall also is protect IT and data from unauthorized access from outside the internal networks. Firewalls are everywhere. So we talk around, like, for example, within home networks. Your in effect your local network, your wireless access point, serves as a firewall that separates your internal your home network, from the internet. So the same kinds of functionality, same kinds of technology are used both on corporate networks and on home networks. All right. In its simplest form, it basically blocks traffic from certain locations and allows traffic to pass through from other ones. Different ways it will do this. It has a bunch of different techniques. The simplest form, first generation one firewalls, packet filters. Basically, you match the packet, you read every packet, and you match it up against a set of filters to decide whether to let it proceed or to discard it. Another approach, within firewall, something called proxy. So the idea is that a the firewall will actually receive the information and will actually serve as a blocker between the 2 points. So rather than just letting it pass through, it'll actually send it to an intermediary address before actual delivery to an endpoint device. So a proxy is, so it's another one-off. So rather than just simply just filtering and examining packets, it'll actually redirect packets to a different address or device, which will then handle the routing to the destination. And then third I guess control mechanism that's in firewalls, and this is what most modern firewalls have. Something called stateful inspection. Basically, it compares key parts of the packets to really a set of signatures, and verify that the content is the packets are valid. So this idea of stateful inspection, the idea of being able to be able to analyze multiple packets and identify them and tie them into sessions. Because don't forget, what will happen is messages, actual communication, as we think of it, is actually it's handled through packets, but basically multiple packets make up a communication. So a lot of what the stateful inspection will do is actually assemble things together and then gain insights and then do evaluations. So firewall filtering, if can block all traffics from a particular firewall, can block all can block based on ports, block on any number of content that's in the packet header. Right? Can block by domain names, can block ports, can block specific words or phrases. All right, so there's a whole bunch of different criteria. Anything you can find within a packet, it can potentially be used as a firewall can potentially use as a means to filter traffic. Protocols, and actually most importantly, protocols. I mean, in protocol, there's different kinds of protocols. So IP, TCP, UDP, HTTP, FTP, ICMP. These are that the alphabet soup of different protocols. You can block using that particular protocol or that particular port that goes to that. So you can firewalls have gone from being relatively simple to fairly sophisticated. So the ability to be able to read traffic, perform different types of analysis of the data that's being passed across in communication, and then make decisions about that has actually been significantly improved over the years. In addition, if you think about the volume of traffic that goes through these firewalls, a very basically a firewall is a fairly really just it's a computer basically. It's another compute platform. It has processors, it has memories, it executes programs. But specifically, it's designed to execute very rapidly because what will happen is you're getting a communication. Now you're talking about 10 gigabit, getting up to multi-gigabit communication lines. The amount of traffic that goes through that, and checking all of that traffic and being able to do that stuff is one of the challenges, because what will happen is that the cycles it takes inside the firewall is cycles that basically can effectively um, slow down network traffic. So one of the big challenges is being able to do the stuff, be able to be effective at it, and be able to be efficient at it. So you want to be effective insofar as blocking everything, but you also want to be efficient, so you don't want to lose any. You want to minimize the amount of traffic bandwidth consumption, basically how much your throughput. Okay. So a packet filter operates at level 3, network layer of a router or hardware firewall. It will block traffic based on source, destination, addresses, ports, and protocols. It doesn't really operate at higher levels, right? So it operates at level 3 in effect. For higher level, you can use application proxy firewalls. So these are a little bit more sophisticated. Um, it runs an application space. It will actually do some kind of special gymnastics to be able to add information that can be then evaluated. But you can do things like some of the things you can do is actually look for things like ActiveX. You can filter out bad URLs. You can make sure suspect, because theoretically anything that you know hackers will use all sorts of different techniques to be able to gain access, or there's known things. So the idea is to be able to identify things like Java or ActiveX. Basically, a lot of the stuff used to be like applets. Applets and ActiveX controls were well-known attack vectors. So being able to have your application be able to deal with this in application proxy firewalls, be able to identify it, block it, or provide alerts or whatever have you. So this is all types of things that are inside of what we would call an application proxy firewall. Stateful packet, this is really the newest, kind of the newer um, form of firewall. We can reconstruct layer 4 traffic, and as opposed to in addition to layer 3, you can do more context and defining context and being able to do more, basically more in-depth analysis of the traffic. This idea of being able be able to take packets, assemble packets, and then doing evaluations of the contents of those packets. So the idea is this is the um, once again, as I say here, it can be expensive. It requires overhead, but it can be done, and depending upon the particular circumstances, may be a valid or a good choice, in particular around different types of application scenarios. An identity-aware firewall is one that basically can identify, um, authentication, basically being able to do authentication, leveraging back to authentication uh, platforms. So authenticate, authorize, AAA account, authorize account. So going back and using credentials, because for the most part, packets in and of themselves are just simply flow across the internet. This actually, will identify packets and associate it with a particular identification, and then we'll authenticate against that and allow for authorization. Once again, being able to, uh, you know, more of an integration back into, say, for example, an ACL that would be at an operating system level. Being able to move that out and to put move that stuff farther out and make it accessible onto a network. So this is once again a newer, also once again requiring some pretty sophisticated configuration work. But once again, this is something that can be done, and depending upon the circumstances, might be a good solution. This is just kind of an example of what we call radius server, how traffic moves from inside outside, and then use going back into this AAA server to basically bring in the ACLs that would be matched up provide authentication. So a couple of challenges around firewalls. So as I said, firewalls have been around. They've gotten very sophisticated, but there's still challenges. Say, for example, end-to-end security. If you tunnel through a firewall, if you use encryption, VPNs, basically it hides the data that a firewall usually would filter or sanitize. One of the challenges you've seen in countries like China, where they've actually have gone back and they have basically forbidden the use of VPNs because basically you can't read the traffic as it comes through. All right. Also, the idea of where the line between it falls between different types of security domains. So, say for example, um, you know, dynamic addresses with DHCP and laptops. Where does that fall into play? The idea is that firewalls assume a perimeter, but if you don't have a perimeter, or if you get into situations like, for example, and we'll talk a little bit with the zero trust networks of like basically putting you get rid of the firewall, you kind of move away from a perimeter focused security to something around kind of more intrinsic security. That'll be something that comes into play. And then also, things are not cheap. Total cost of operations on large networks and sophisticated networks, getting more, is very high. And then the question is, can you maintain the effectiveness of this stuff? So part of the stuff we'll see, as we talk around kind of this rethinking of this stuff with new approaches, like for example, zero trust, the implications of that on firewalls. So this is just kind of a list of some of our well-known ports, some of the different things that are out there, and kind of what there are 10,000 TCP/IP identifies 10,023 well-known ports that can be used. Port security. I mean, the whole idea of port security is you basically, if you don't need it, you don't enable it. Right? One of the challenges is by default, most operating systems, activate everything. Everything is enabled by default. So it's like the idea of a waitlist versus a blacklist. So the idea is instead of what you want to kind of move from is an environment where instead of everything is enabled by default, is that nothing is enabled by default, and it has to be explicitly waitlisted. All right. So, for example, we use an example here. Server acting only as a web server should only run HTTP or and SSL, and every other thing, every other protocol should be disabled or removed from the OS. So you want to look at the functions. What is this? What does this machine do? What protocols does it need? Only enable those, and then take everything else off. This is port security is probably um, one of the biggest security attack attack vectors that are out there, primarily because historically, you know, the default approach has been to just enable everything on IP, and everything is known on IP, and everything is a potential attack vector on IP. And by doing this, by making it smaller, the idea is you reduce your surface area for the attack. Port scanning, basically, port scanning is ubiquitous on the network. Basically, everything is scanning everything on the network. All right, so the idea is, from a preventive maintenance perspective, or from a protocol, from a procedure perspective, the idea of doing, port scanning on a regular basis, on an organization's regular basis, and basically defining what are valid ports, and then scanning to see if anything is outside of that is a best practice. So, because what will happen is a lot of times, machines, protocols, things can just show up unexpectedly. So the idea of the assumption should always be that trust trust nothing, as it were. Intrusion detection. So intrusion detection, we talked about this before. The idea is the idea of looking at behaviors, and looking for different activities that would potentially be some sort of indication of some sort of attack, or behavior that would be worthy of evaluation from a security perspective. So this idea of anomaly detection, misuse detection, use of statistical work, big data would be an example of being able to go through dumping all of your log files out, doing statistical analysis on it, and then looking for anomalies against that. Is really part of what intrusion detection is. Intrusion detection has actually been something that is kind of, as it's evolved, is basically been, in a lot of cases, simply gets baked into the functionality of a firewall. It used to be a wholly separate functionality over and above a firewall. Now what's happening is being baked into the firewall itself. A couple different types: host-based, network-based, knowledge-based, behavior-based. So those are the kind of the four. So this can be done, on a machine, on a host machine, monitor activities, on a network, which would be, basically can be associated with the firewall. Knowledge-based, which would be, basically creating signatures of activities that could be matched up against, and then behavior. And actually, what happens is a lot of modern malware, things we call advanced persistent threats, are behavior-based. So you don't really know it's there until you watch for its behavior. So you have to kind of establishing a baseline of what is considered normal behavior, and then kind of watching for variance on that is really what this is about. This is what this type of intrusion detection approach is about. The idea of intrusion handling, preparation, identification, containment, eradication, follow-up phase. So the idea is that and this all needs to be defined really in advance. This is something from a security manager's perspective, security architect perspective. All of this stuff needs to be, combination of an ongoing. It's an ongoing effort, just basically baked into the way the operation, basically baked into your security operation. Continuous improvement, continuous monitoring, continuously, evaluating for new types of attacks. So it's a never-ending process of improving and tightening and hardening environments. Honeypots have been around a long while. Actually, they're still pretty valuable. Some interesting stuff, especially when kind of understanding behavior of attackers. What you do is you basically put a fake system out there, and let attackers come after it, and kind of see what their activities are and kind of what they do. Interesting to see to be able to kind of develop, establish patterns of what they're monitoring or what their reconnaissance looks like, kind of what their modes of operations are, be able to kind of capture that and kind of use that to bake into something that you could use as a signature, for intrusion detection. So it's sort of a, you know, so one of the trick is that um, it's also well known on the attacking side as well. So it might not be quite as effective as it used to be, but it is a pretty well established, and it still has some pretty good value from a security perspective. So the architecture, the idea of kind of creating an intrusion detection architecture, scaling from low levels to the lowest level of the infrastructure, scaling up into a central collection repository. A lot of this stuff is all kind of built around kind of a hierarchy of rolling up into like having a central management environment, taking data feeds from basically everywhere across the infrastructure, being able to pull that stuff together. So it's a pretty well. It needs to be a well-established, well-designed, well-executed architecture. It's not something you can just slap together. So the idea of being, trying to determine, what operates at what level, kind of building it up, and then being able to analyze information on an ongoing basis. Because this actually can take there's a fair amount of effort to gather information, on an ongoing basis, and to effectively use the information that's captured to identify intrusions. So we talk about the components of it: a collector, an analysis, a signature database, and a reporting interface. But this is kind of a high level architecture of this. But this is what kind of the basic components, the four basic components you would need, and you would see in an intrusion detection platform. Sources for analysis: direct data, and also indirect data. So a lot of times, what you'll get is direct data is basically analysis of what's coming through the firewalls, what's being observed. Indirect data can be mainly log files. Log files are incredibly valuable. And what's happening in most organizations now, we're discovering you can gather more and more and more information, and be able to use like big data techniques to grab information, to process it, to work with it, and to use it. Misuse signature detection. Basically a lot of what you're seeing is kind of this idea of fixed signatures. What we're seeing more and more and more of, though, is this idea of trying to use machine learning and use machine learning techniques to be able to identify. This is an ongoing. It's a cat and mouse game between attacker and attackee. So the idea is that is attackers can also understand kind of what organizations are looking for. So the idea of being able to take one standard approach and expect it to work continuous, forever, is probably not a valid one. So a lot of this stuff is the idea of trying to do the challenge. Probably the biggest challenge in a lot of these cases is what we call false positives. All right. A false positive will you know is really disruptive, because what will happen is it will throw you off, because what will happen is if you start getting more false positives, people will not believe when you do get a real positive. So trying to filter out a real positive from a false positive, you know, people's perceptions of well, that's not really a problem. All right, so trying to tune these things exactly to get the right fit, to filter out and continuously improve, so that what it's detecting is legitimate stuff, not fake stuff. So it's a hard, and as I said, this is an inexact science. It's an art. And quite frankly, it's as much of an art as it is a science. Talking about statistical techniques, we did talk about this. You know, the ability of using machine learning. So you're going to see more and more things like machine learning coming to the fore with this. Number one, because of the complexity of the data, the volumes of the data, the complexity of the data, the understanding and trying to identify behaviors. All right, so this idea of a self-learning intrusion detection system is something it's becoming something that's in the pipe, something that's in on the progression of what we're working with right now. So host-based. This idea is you can put intrusion detection at the host, you can put it on the network, you can put it in a couple different places. So you can either way. In some cases, you can say it shouldn't be an either or decision. It could probably be at both, and basically have a tiered intrusion detection platform. You know, Basically, a network versus a host. And it's like I said, it's not. It doesn't necessarily have to be an either or type of thing. Uh, Classic intrusion detection, network intrusion detection kind of layout. Incident response, part and parcel of, how do you identify it and what do you do about it once you define an incident, once you've identified it, you have a real incident and it's a real result. What do you do about it? So the idea is, deflection, detection, countermeasures, uh, and this is making sure that you've got the right, what is a, you don't, making sure that taking countermeasures, making sure your countermeasures, you have you know, a legitimate positive event to take countermeasures against. Intrusion protection, which is kind of a new thing, basically. Once again, it's not just detecting it, but actually doing something, taking some sort of action on the other side. Attack. Basically uh, disconnecting, um, you know, routing information, kind of doing different kinds of things. Um, but I like, one of the things to think about as you're looking at this stuff is, um, you more sophisticated intrusion detection is really kind of circles back, and it's kind of like very clever firewalling. So it's not that much different. I mean, a lot of the same things. A lot of it is volume and speed and sophistication, but in effect, it all comes down to kind of this idea of a firewall. So this is just some guidelines around a security, some of your basic steps on, and establishing security, and establishing by type of machine, by classification of machine. So once again, this would be something a security organization would define as policy and maintain and monitor. And some basic security, server security principles, you know, simplicity, fail-safe, open design, separation of privilege, least privilege. These are all core principles that need to be baked into any policy, that any server security policy. So this is also some guidelines around kind of what you would do about security, installation and deployment. Some best practices you'd want to take a look at from a design perspective. This would baked into your. This should be baked into procedures of how things would be done, policies, and then supporting procedures that implement those policies. Server OS, server security, the OS ongoing patching and updating OSs on an ongoing basis becomes basically the one of the most critical things that needs to be done from a security perspective. Basically maintaining security, maintaining patches on an ongoing basis. Because what happens is security is, the targets of, especially with operating systems, there are, it's an ongoing issue. So being able to deal with it in a fashion where it becomes manageable, controllable, understandable is critical. So this is just some other server security uh, processes as well. Maintaining it, things around server logging, backup procedures. This is all part and parcel from an operational perspective. This is what you would see all of this stuff baked into how an organization would structure its security. Some of the basic components around this stuff: security domains around perimeters, intrusion detection, um, intermediate enforcement. You can do some things around denial of service attacks, but primarily, a big portion of this stuff is secure server configurations, both on the initial setup and then ongoing to maintain and sustain that. And that is it for topic number 9.